Hi guys, in today's session we'll be covering how to code the line plot and the bar plots using Matplotlib, Seaborn, and Plotly. Okay, so we also have Altair, which is another method in addition to this, which has been given in the notebooks. But you can go through that on your own when you have free time and get back about that. But we'll be discussing these three mainly today because these are the most popularly used modules from Python in order to perform our plotting of major charts required. So let's get started with today's session. In order to import, we have a very simple way. We just import the matplotlib.pyplot as PLT, as you have seen yesterday, where we also used the same module. And in addition, today we are looking at Seaborn as SNS and import plotly.express as px. Now, you'll be confused. Why do we have three different visualization modules? Like, what's the difference between them, right? So, what do we go for? So, it's not like this is the best or anything as such. It depends on the use case, okay? So in case we are going for Matplotlib, it has a lot of customizations available in its code base. So we can make it exactly like how we want. So that's the advantage of Matplotlib. But however, on the other side, when we look at Seaborn, it is used for automated plots and it is also based on Matplotlib. It's like an additional layer over Matplotlib to make the same code a little more easy and like something which is easy for the people who are plotting it. Since we have a little complexities or the syntax is too complicated in Matplotlib. Okay. And we also have Plotly where we have a lot of interactive plots. So I know that it's still a bit vague, so let's go into the details. So once we come and look into the Matplotlib, which is a foundational library where we have a lot of customizations at hand, okay? So we have a lot of static, interactive, and animated visualizations. So you have seen until yesterday that we just have simple, basic plots. Today, let's see how each and every single aspect of it can be modified in a way and so that we can fine tune it to our liking so that it can be made more comprehensive and understandable, right? So the advantages of this is firstly, as I said, the extensive customization, and then we have the fine-grained control over the plot aesthetics, and also it supports a wide variety of plots. So we have line plot, bar plot, and area plot. We have a lot of plots, right? So some of our modules, they may or may not support. In the case of Matplotlib, it is a very good, it has support for a lot of the plots. So we can rely on Matplotlib. Okay. However, the con is that we have to write a lot of code to do the same thing. And the learning curve is really high. So now let's move ahead. And when we go to Seaborn, it is built on top of Matplotlib. Okay. So most of the base code is going to remain the same as Matplotlib. However, wherever it's possible, the developers have made it in such a way that the code is much more simple to achieve the same goal as what we do in Matplotlib. Okay, so we'll get a very similar plot, but which with some few lines of like reduced code. So we don't need to remember the syntax that accurately. I mean, we don't need to know the syntax, but it's little easier to remember the same syntaxes to achieve the graphs, right? So what does it do? What are the pros? It offers built-in themes and color palettes. So when we have built-in themes, we don't need to go and explicitly mention any of these. So it's taking care of some of the parts on its own, right? And it simplifies the creation of advanced statistical plots, which includes box plot and line plots. And moreover, as I discussed yesterday, it also helps provide support for the multivariate relationships. We are still looking at the univariate relationships as of now. So going to the cons, though it is easier than Matplotlib, there are some limitations in terms of customization. Okay, because when we have Matplotlib, we have a lot of customization. However, it's a lot of code. Here, it's lesser code but limited customization. So, depending upon our use case, we must select the appropriate one. And finally, Plotly, which is my favorite since it's the easiest to explain it to you guys. With just a couple of lines, we are doing what is required to do in Matplotlib and also in Seaborn. It's just a couple of lines and you'll see the difference in the ease. So, Plotly, it focuses mainly on creating an interactive and dynamic visualizations, okay? So that we can embed these into a web application or a notebook. So once we go into the implementation, I'll show what you mean exactly by creating an interactive and dynamic visualization. So what are the pros? It offers dynamic and interactive visualization. It supports wide types of charts, including 3D plots and geographical maps. And also it enables the creation of interactive dashboards and web pages. However, it requires more resources for rendering. We know that Matplotlib, being the foundational module for plotting all our graphs, it has been made really interactive, but at the same time efficient. It doesn't take a lot of resources, but however, Plotly, due to since it is trying to make it as abstract and as simplified as possible, and other reasons such as making it compatible with the website or even the notebooks with a lot of interaction, is going to take a lot of resources, which depending upon your hardware might take a little longer time to render, right? So learning how to use it effectively, it might take some time because we need to know where to use it, when to use it. So this is all would be the overview on Plotly, Seaborn, and Matplotlib. Okay, so what we'll be starting today or covering today will be mainly about line plot and bar plot. Okay, so line plot and bar plot. First, let's talk about what's line plot. As you can see in the image, it's the one towards the left. A line plot is a type of chart which displays information as a series of data points connected by straight lines. I think by the look of it, this is quite straightforward. It's most commonly used to visualize how something changes over time, okay? Such as the temperature by the day, sales by the month, and so on. The x-axis, it typically represents a continuous variable, which is, for example, a time or a sequence, right? So we can put the date here or a sequence of numbers as something progresses. While the y-axis shows the corresponding values. Time plots are especially used or useful when you want to observe trends, patterns, or fluctuation in the data. So when, for example, the first example that I said, right, the change in temperature day by day, we'll see that one day it's gonna be increase in temperature and one day it's gonna be a decrease in temperature. So it will be easier to notice all this. So you can also plot multiple lines on the same graph to compare the trends across different groups, right? So when you do that, we can look at the temperature change across different countries or different cities, different states. This allows us to compare using the same graph without making much difficulty in the comparison side, right? So with their simple design, line plots make it easy to spot things like rising trends, seasonal cycles, or sudden drops, as we can see in the last, towards the end in this graph. And the other graph that we'll be mainly covering, it would be the bar plot. So the bar plot is a fundamental chart type used to compare values between distinct categories. Okay, so each category is shown as a separate bar with the height or the length in the horizontal bar plots. So right now we have a vertical bar plot since it's facing towards the up and it grows towards the up. However, the same thing, in order to make it little more comprehensible, we can make it also as a horizontal bar where it will grow towards the along the horizontal side. Okay, so the bar plots are excellent for answering questions like which group has the highest average score, or how many students belong to any particular class, or what gender or what ethnic group. So when we have something to group by, right, it's more like logical to use a bar plot. So they provide a clear and visual comparison between the groups and can be either vertical or horizontal depending on the layout that we prefer. Bar plots can also be grouped side by side bars or multiple variables, or they can be stacked one upon the other to show a part of the whole. So, for example, let's assume that here ABCD represents the class of students. So, A section, B, C, and D. And if you want to split the same data into male and female, we can put them side by side or stack it one above the other such that the aggregate will come to the same. But since they have a different color, we'll still be able to see the proportion among the subgroups, right? So they are ideal for categorical data and are easy to interpret, but they are not suited for showing trends over time. So that is where we have our line plots, which is a better one for change over time. When used well, the bar plots are one of the most effective ways to highlight the differences or rankings between different categories. So this is the strength and weakness among our different types of plots. So these are the two kinds of plots that we'll be covering today mainly. And we have some additional ones here and there, which you can go through on your own. And I'll be giving a gentle introduction and we can continue discussing on them tomorrow. Okay. So let's begin with the first session. I think have you guys seen the course portal? So this is the course portal for today, where we have all our codes related to the today's course. If you can scroll a bit down, you can see data visualization code day 2. Once you enter this, you're going to see the notebooks from 1 up to 10. Yesterday we covered the notebook 01, 02. Today the plan is to cover from 03 to 010, and you'll have some homework in the middle which you can look at, which I'll be telling you and explaining today. So did any one of you go back home yesterday and try to set up UV and run all those codes? So to begin with, we'll be going through line and area plots with Matplotlib. Area plots, I'll give us a brief introduction once we go to that part. So today's data set, we'll be using a NASA-based data set where we are checking the global surface temperature analysis, which is from 1880 to today. So this is how the data set looks like. Okay, we load it from the source using pd.csv read pandas, and we're just giving the path along with it. Now, once we put data, we are able to look at the overview of the data that we have in our pandas data frame. So as you can see, we have a lot of um, categories over here. So what does each of these signify? So as you can see here towards the left is the year during which the particular change in temperature, the global temperature, has taken place. and each of them are categorized by the months from January to December. Okay, and once we reach December, we have these kind of separation. And what are these? So J to D is basically an annual change. Since we have January to December, and a cumulative one of them would give you the annual change. Then we have December, January and February, March, April, May, June, July, August, September, October, November. So it's like every 3 months distance, we have one representation over here, one for annual and one for each of the months. Okay, so let's go ahead and see what this data represents. How is the data going to look like when we use the inbuilt pandas describe function? So when we do that, we just need to do data.describe and a dot t. Why is this dot t? I think we did not discuss about this ever till now. Since we have the year in along the x-axis over here, which are in the columns, we need to make it into the rows so that we get the count, mean, standard deviations, and min max along the columns, right? So when you do transpose, the columns become the rows, and each of these descriptions, they go to the columns. Okay, so it's more interpretable now for us than before. So once we see this, we can see uh, what's the min year. So as I said, it starts from 1880 and goes up to max. So our data set is updated up to 2021. Okay, and similarly for Jan, we can see the maximum change in temperature that has taken place since these many years. That is around 41 years, right? 41 years. The max change is noticed here, and at the same time we can see the mean change and other changes throughout the months. So we can find some sort of a correlation here. But isn't it a little bit too difficult to go through each of these values and understand them like one by one? Which is why data visualization comes into a lot of help. And when we go to the line plots to plot this, first let's use the most simple way to plot a line plot. So we just need to do plt but style.use default. This is nothing, you don't need to worry about this because it's just setting a default styles so that we have a lot of supports to different styles where we can import ggplot or other styles which can give a much better look. Okay, so we'll come to that later. So to make this particular plot, all you need to do is provide the data frame and type dot plot. So here our data frame is data of J to D, which is December to January. So we are seeing the annual change in the data, right? So when we look at the change of the annual deviation in the temperatures, we see that initially it goes up and then it starkly goes down, again up, and it moves so on. But do you see that since we're using just one line of this code, we're losing a lot of data. What is the graph even signifying? I know the reference, but what if someone else comes? He has no clue about what's happening over here, right? Also, what is 0 to 20, 0, 20, 40, 60? We were just talking about the years, right? And also, what is in the y-axis? Why is it going to negative? We're talking about temperature. How is it stopping at 1? We have a lot of questions. So, which is why we have to make a lot of changes to this code in order to make it as aesthetically pleasing and interpretable for the people, right? So we are making some changes. So the changes, we can create a dictionary for that called plot style, and we can pass all the variables when we plot it. Okay. So we're changing the size. If you want, we can use latex, which has been disabled by default. Once you can install it in your computer, it will start working. Okay. So we have set the font size, the font family, font size, label size, title size, like basically how you want it exactly to look like. We can make those changes in this particular dictionary and then pass it to the parameters later. So we have the DPI also. So this will like require a little more stress on your computer to display because it's a high DPI. Then the figure size where it's x comma y, sorry, and then we have the title size as well. So once all of these are set, let's go ahead to the plotting time. Initially we had used a default style, but now we're going to use ggplot. Don't you see the difference already? We have a different types of grid layout in the background. We have a grid layout in the background and some sort of a font that is being set. This is all because of the ggplot in combination with the plot styles that we're saying by rcparams.update. So a combination of these two has led to so much change here. And in addition to that, the around this, as you can see, we have this legend, we have this super title and the title, right? So that's given here as a super title, plt.supertitle with the font sizes, and the title which goes below with its smaller size. And also we can set the line color explicitly using color, and this legend over here is given by the label, and we activate it using plt.legend. Okay, so a combination of label and legend for the legend to be visible. The color can be set explicitly. The background can be used by ggplot theme, and the other uh, variations such as the font size here and there, it can be set and updated in the plot styles dictionary. So we just went from a single line of code to I think 15 to 20 lines to create a reasonably looking plot. So you can see that the number of lines are piling up, right? So as I said you in the beginning, we have the other methods where we have Seaborn trying to optimize Matplotlib, and also we have Plotly, which is a completely different approach but little more intensive due to its abstraction level. So moving ahead, let's see. One more thing that's lacking here. Don't you see that this is 0, 20, 40, 60? It's not going to make any sense to the person who's seen this, right? So what do we do here is we're going to set the x-axis as the year, since in our data set, right? In the data set, we have the year, but it doesn't know that that's the year it's supposed to take. It is taking the index by default, which is why we have those detail. We have those numbers in the x-axis. So once we set the x index as the year, it's going to take this and plot the same, right? So when we explicitly make that change by giving x as year and y as JD, we have and we have what this is. We have the year here, which is explicitly mentioned like what we need it to be, right? Now, another changes, you can see that we have put the year here and the temperature deviation in degrees Celsius towards the x-axis. That is done. I think I discussed this yesterday using the y label over here, and x label is done by default since we are explicitly mentioning the x label. Okay, so we have gone from something that looks so simple like this and not interpretable into something which is much more better, much more interpretable, and aesthetically pleasing for someone who's trying to understand it. And we also have a legend, which means something, right? So, how do we move ahead? We have a reasonably good plot right now. We can go ahead by looking at the changes from every couple of months deviation, right? So, in our data, we have another set of categories where we see the deviation from December to February, March to May, and also from uh, and also for the other 3 months, right? So what do we do now? That is June, July, and August, and also September, October, November. We can use these as well. So let's look at that. When we plot that, we're going to get something like this. But before I explain about this graph, let me explain how do you get this done, okay? It's quite simple. We just need a simple for loop, and we're creating a data frame for each. Once we have a data frame, I think you know what's to be done. It's plt.plot, right? That's all the one lines that was needed in the beginning of our session. So let me go into it in a little bit more detail. So we have seasons is equal to data.columns.toList. So it converts it into a list type from which from 14 to the end. So why is it 14? Here we have to start from here, right? So this is the 14th index where we count from, okay, we have year, we have 12 months, and we have JD. So we have 13 over here, right? I mean, since the index starts at 0, we have 13 over here, and the 14 to the end is what we need. So that's why we have 14 colon, which means everything from 14. Once we do that, we have a data columns of two list 14 colon. So we have the seasons here. Now for each of the season name, right, we have a for loop. And in each for loop, we are taking and separating out the data in order to get our season name. So it is going to be stored in seasons data. Okay. Now, when we set the index for each season, we're going to set the year as we did before so that it is shown in the bottom here. And we're going to keep in place and true so that they overlap and we have a single graph which is more concise. Now, when we plot this, it's going to continuously overlap one of these other on top of the other as and when we go through the for loop. It's going to happen too fast, so we won't see that small iterative change, but that's how it works. Now we activate the legend, super title, y label, and title layout to make it as concise as possible instead of a very big plot. Okay. So what do we do? What do we see here? We see that there's a lot of changes here, and it's not that very interpretable. And why is that? Why do you guys think that this is very difficult to interpret as of now, as the same way that we have? Can anyone type or open unmute their mic and say what makes this difficult to understand? The lines, they're too clustered. There are too many changes in like extremely small intervals that we cannot like interpret it unless we do something like uh, we open it separately, zoom in, and try to like nitpick each one of those changes like this, right? Are you like happy with doing this? No, no one will be happy. They're gonna go crazy after some time, right? So what we're gonna do is instead of taking and plotting each one of them for every single year, right? We are going to plot them for a group of years. In such a case, we still have the entire essence, but at the same time, we can see the entire deviation in a much more simple way. So it's going to look something like this. Don't you think that immediately in like just with, I think this is just one line of code on top of what we had done before. We're just grouping each one of them by 10 years. We have 1880 to 1890, and we can see that it's much more comprehensible by us, right? So it's like uh, when there is lesser cluster and lesser things happening in a graph, it's easier to understand for a given person. Okay, even though that has more statistical meaning here, it's about interpretability. That's why we have visualization, right? How how is it like? Is it interpretable? Is it like so convoluted that we cannot even understand? That's not the motive of having a plot. We need to make it as simple as possible in order to humanly observe the changes. So let me explain how that is done. It's just one line on top of what we had done previously, but we're just grouping by each of the seasons, okay, through index. We divide it by 10 into 10 and a mean, which gives us a group by season. So why are we doing that? We have like say 1880. When we give by 10 and start 10, we are going to get the 10 out, which is going to group each of these. And once the mean is done, we're going to get from a range of 1880 to 1890, right? So that's how the group by is going to work. And everything else in the code, it remains the same. Okay. Now, Finally, let's come to area plot. Okay, so what's the other issue in this particular plot? What do you think? Like here, we can see that in some cases it's going up, it's going down. It's going down here too, but we might think that okay, might be a flat line or it might be going slightly up. We don't know exactly how much each one of these are going up and going down. I mean to say, what is the change? How much is it varying each year or each decade? Are we able to understand like by what magnitude each one of these are changing? It's little difficult, right? We can't keep subtracting each one of these data from the y-axis in order to understand what kind of a change is taking place. So in order to do that, we have something called as the area plot. So this entire graph will just work on the entire year's data. It's going to be converted into something much more simple. So you can understand it like this, okay? We have it from January to December only. We have not clustered it with multiple months. So what do we have over here? An area plot it is very similar to a line plot, but it has the area under its line filled with a particular color, making it useful for showing not just the trends but also the magnitude of the values over time or in categories as well. Area plots, it helps to visualize the cumulative totals. So as you can see, before we were seeing just the variation, but here we can see that each year in the beginning it's tending to go more towards negative side. So the temperature was decreasing. Only after this 1940 did we ever see that there was an increase, right? So when did we like really understand that? Like yes, we were taught that it starts from here itself, but the reality in that is that it started only at 1940, right? So what does it do? We are understanding the cumulative totals of how different parts contribute to the whole. So you might see an area to use an area plot to show how the scores of different subjects add up to a total, or how number of students in different categories change over time. We have a lot of uses for area plots, okay? So right now we are using the temperature change as one of the examples to explain the same. And also when multiple variables are stacked in an area plot, you can compare both individually. So the individual contributions and the total, overall total, both can be visualized. So basically area plots are more visually appealing and are good for emphasizing the volume or the accumulation, right? Because basically what are we seeing? A cumulative result. So so this is how we are going to go ahead with the plot of the same thing. And how do we do this? It is a very simple code as well again, but here we are doing data.plot.area. It's just as much as that. Give the same x, same y, set our color, and we set stacked is equal to false. Okay. Stacked is when we have multiple different data that we are going to plot. Then the legend, super title, y label, and type layout. That's the same as before. And then let's go into something else. This is more like a variation of the area plot, but you might have small difference, right? You will be able to see the magnitudes little more distinctly, and we can make a change over time in the color. So it's going to look something like this. It's the same plot, but okay, let me first explain what is this. It's called as a vertical line plot. Okay, so when we come to vertical line plots, vertical line plot is in Matplotlib. Okay, it is not a standalone chart type, but rather a visual marker that you can add to any plot. Basically, it draws a straight vertical line in a specified x value and is especially useful for highlighting important events or thresholds. So as you can see, we are here, it was little vague about what are the magnitudes. Even though we had a better idea, don't you think that these lines give a much more representative idea for us to understand that? But at the same time, it's not making it too clustered for us to understand. It is interpretable, and at the same time, it's giving the same meaning as this, along with the magnitude, which looks more sharper and understandable, right? So this is why we use the vertical line plots. So to do this, we just have to do plt.vlines, and everything else remains the same, and except one thing. Here, ymin, we have a np.zeros, right? The data of year and dot shape equals 0. Why is that? Because we need each one of these lines for each one of these years to be having a minimum starting at 0. And if it's a negative, it has to come down. And if it's a positive, we have to make it go up, right? So that's why we are using this particular line, so that it's set as a base of 0 and it moves towards each of the other sides. Okay, so that's the idea about that. And once you said that, we're going to have this entire plot. Otherwise, it's going to be all pointed towards the other side. Now, to make this little bit more like interesting, what we can do is we can give a change in the temperature. So along the change in the temperature, we can have different kinds of colors, right? So up to the maximum increase, we can give red, and for the maximum decrease, we can give blue, because that's the meaning of increase and decrease in temperature. So when we do that, it's going to look something like this. Don't you think this is much more better? Like, yeah, we don't need to look at the changes by just like having an overview of the colors. We can see how much and where do we have the maximum increase or decrease in temperature. This is just one line of code. Okay, so we have color vals. So what are we doing? We're doing min-max normalization. So what are we doing? We're taking the minimum of the entire values. So I think somewhere over here, a negative 4.5, and the max. The max would be around 1.1, I guess, 1.1, 1.2. So when we have a min-max, now all we need to do is create the variations in between. So when we do the min-max normalization, we're going to get all the values in between, and we're passing that to a plt.cm coolwarm, so that the coolwarm, which is a change in color method, is going to be given a parameter of color vals. So these are the colors that are determined by the change here. So it knows for what value it has to give the darkest red, and for what value it has to give the darkest blue. So this is how we are doing this plot. So I think we are done with the first Matplotlib lesson. Now let me start the Seaborn parallelly, since that's, as I said, as I explained to you in the beginning, right? The Matplotlib and Seaborn, they are very similar. Okay, Seaborn is built on top of Matplotlib. Okay, but it's only trying to make the code a little bit more easier. Okay, it is trying to make it something which we can understand in comparison to the very complicated method which the Matplotlib uses. So the beginning remains the same. Let me just show you the changes so that we can go ahead fast. Okay, we have a lot more to cover. So, okay, coming to our first plot, you can see the first change here. We have sns.line plot. In a single line, we are already able to set the data, the x-axis as here and the y-axis. So you might think we just did the same thing even over here. We're just setting the x-axis and the y-axis over here, right? But the difference is SNS in Seaborn, it is a requirement. So if we do the same thing, right? If we remove this, it's not going to let you display the whole thing. It's a necessity for the parameters. So only when you do that, we're going to have the entire plot. So already we have year over here, and the index is all sorted, which was a lacking in Matplotlib. And it's all done in a single line, right? Otherwise, we have to give X label, Y label, and as such, which makes it a little bit more complicated. So in one line, we're already beating what here. It took us a lot more lines to do. Now let's give the same styling for that by using the GG plot. Then we are updating the parameters with whatever we had done previously, and the same line plot, and we are giving a label for it as annual mean. Okay, so that's the legend, and everything else remains the same. We have a super title, a title, and a title layout. So we already have reached the part which took a lot of time to reach in Matplotlib. Now let's do a multi-series plot. Okay. In our multi-series plot, what did we do in terms of Matplotlib? We had given a for loop where we continuously go and we create a different data frame, right? From seasons, we are taking out our required four categories. That will be the 4 months, that is DJF, MAM, JJA, and SON. So once we take that, we are splitting them into individual data frames, and for each of the data frames, we are setting the index, and then we are plotting it. But however, here, once we get our seasons from the data set, we're just going to melt that and we're going to give each of them an individual ID, a value variation that will be in terms of seasons, right? Because these are the seasons, and a variable name called season. So what we do here is when we plot it through SNS, we set this data as what we have extracted after melting. X and Y remains the same. And when we say hue equals season, it's going to like give a different plot for each one of these differences, right? So we have the 4 months. It's going to be melted into four different categories, and the variable for those categories is season. That's what we're saying here. So when we have hue equals season, it's doing the same thing as what this for loop does by creating four different data frames. And also we have alpha equals 0.7, which also helps us a lot. So it just is going to make it transparent so that we can see through and understand the other plots. And again, finally for group by, we're using a for loop now because Seaborn doesn't have a shortcut way for doing that. And when we use the uh, for loop, we are just going to group by using the same formula and the same plotting method. So now there's no complexity of melting down it because we're already in a for loop, we already have the season name and we're already splitting it. So there's no necessity to go into that complication unnecessarily. We are doing a normal SNS plot and we're passing the normal parameters as we did before. So what we get is the same plot, but in a much more simpler way, right? Now we'll go to coming to area plots. That in Seaborn, there is no inbuilt way to do the area plots. So we have to go back to Matplotlib. So I think you already see that the Matplotlib, it supports more number of plotting. Like we already see a lacking in the Seaborn, right? So moving ahead to V lines, we see that it takes a little bit more amount of code, but we are getting a much like more pleasing output, right? So let's just look at how we do that. We set the style as a white grid. However, in this we use a ggplot. And then we are setting the figure size and we have a for loop. Okay. So in this zip, we have data of year and data.set, which is all a list, right? So in zip, we are allowed to enumerate through each one of these data for each one of these plots. And when we enumerate through these, we are going to use plt.vlines. So as simple as before, it's just plt.vlines, okay? We're going to use x equals here and ymin equals 0 so that it sticks to the middle. In the other place, we had done np zeros of data here dot shape 0, right? So that is where we are setting it to stick to the middle and deviate on both the sides. And everything else remains the same, okay? So that's the change. And also we can do the same thing for change the gradient colors. We can just use the same method that we used last time using the min-max normalization for the variation and give that as a parameter along this zip, right? Once we give it as a zip, it's going to unpack each one of these colors and give it as a parameter to our plt.v lines. And here we explicitly mention the color, okay? And we also mention that the line width is 3. So finally, we get something like this, okay? So that is all about Seaborn. It tries to make it much more simple compared to our normal Matplotlib. Okay. So any doubts still what I have covered now? So let's go ahead. So as I told you in the beginning, Plotly, it's the most simplest way compared to Matplotlib and Seaborn. Okay. So the loading method is the same. In Plotly, we get a much better plot. Okay, this was a single line plot when we had done with Matplotlib. And when you come to Plotly, we have a dot line. We give the data that we initially took, X, Y, and the title all in the same line, and we get a much better interpretation already. Now, don't you remember that in the beginning of this course, I told that Plotly is very interactive? I think you can see the answer to that. Do you see anything which is shown when I'm hovering my mouse on top of the plot here towards the left? No, nothing. Okay, let me bring the graph out. It's still an image. It's just going to plot the same thing and I can zoom in here and there. Does this make any, like, is there any sense in that? No. But however, when I use Seaborn, when I use Plotly, we see exact data wherever I keep my cursor, which makes it much more interactive. And at the same time, we have a lot of options here, like download the plot as PNG, zooming, panning, zoom in, zoom out, auto scale, reset accesses. So when we have this, it is much more easier to integrate and we have much more interactability with it. So as I said, another thing about Plotly is that we can integrate the same thing into websites as well. So it's a highly interactive one, but it takes a little bit more time to compute, okay? Or a little more hardware power. Now, moving ahead, we just are giving the little bit of style to the same. As you can see, even the x-axis is sorted over here, since we are already given that x is y here, right? Now we are going to override this and give some labels, and we are going to say that we have temperature deviation in calculus for the JD, that is this, and we have a title on the top, that is temperature deviations. So, and we're also setting the width and the height. Previously in Matplotlib, what we'll do is we'll set the aspect ratio or the size in terms of x comma y. Like, okay, I think from yesterday's class, you have remembered that we'll be mentioning 14 comma 8 to be precise from yesterday's class. So 14 would be what is there along the x-axis and size of the x-axis along the x-axis and the height along the y-axis. Okay. So that is what we are doing here by mentioning the width and the height. So these are the main differences. So you see that we already have a much more comprehensible plot in comparison to this by just a single parameter. I mean, giving more parameters to a single function, right? So there's again limitations to Plotly. It has a limited number of plotting abilities. Like we cannot go extremely complicated, although we can with some workarounds. I mean to say that the inbuilt functions support only minimal changes. Okay, so this is it with respect to line plots. Now we have covered so far Matplotlib, Plotly, and Seaborn. Three different ways of plotting the same data sets data for this particular data set. That is the NASA's change in global temperature data set. Okay, so we'll be moving ahead to a bar plot. So this is gonna take a little more effort to comprehend in comparison to what we were going through right now. So before that, if you have any questions, you can ask now. Also, the notebooks are very self-explanatory. So coming to bar plots, since I hope you guys would have remembered from last time that line plot, it is for displaying information that has a series or a change over time. But bar plot, it is a fundamental chart type that is used to compare distinct categories. So each category is shown as a separate bar with the height. So it depends on how you plot it along the vertical line, vertical side or the horizontal side. So that's just a recap of what I had given about that in the beginning. So today today in this part we're going to be taking a different data set. So we're going to take the COVID data set where we had on a particular date as of Jan 2020 the region and the confirmed deaths recovered and the active counts. So we have four different categories over here. Okay. So pd.read CSV is a simple thing. So That's common from yesterday's course. There's nothing changed in that. And once we go ahead, we just need to use data.plot bar. When we do this, it's more than enough for us to plot this when we give that the x is a region and the y is confirmed. So as you remember, we have a region here. So we get the region along the x. So these are the categories that I was saying for bar plots, right? And along the y is the confirmed count. Since it's a count, it's going to have a confirmed there. Now to just make this little bit smaller and concise, you think this is too long, right? So we make this more concise using the type layout, plt.type layout. So it's still a two-line code, okay, using Matplotlib. Moving ahead, don't you think that this over here, being typed here vertically is little inconvenient, right? So what do? We can probably keep it as a slanting line. So it looks something like this. How do we do that? We can do that by using the x text with a parameter as rotation equals 30. We can also give a negative number so that you can look at the other side, but that will be upside down, uh, not the right way up. Okay, so then there's another observation that here we see 0, 2, 4, 6, 8, right? But however, let's come to our data. What is confirmed? It's in much higher like scale that is not being captured by our basic setting of y equals confirmed. So what do we do here? We just need to set that our axis y and style equals to plain so that it takes the exact same data as in the data set and displays it over here along the y-axis. Okay, so by doing that, now we are able to see the entire representation of these numbers. Moving ahead, now what is the drawback in this particular format? Can someone tell me? Like, do you see any drawback here? What is the drawback with the current plot?
I guess the y-axis scale isn't super detailed.
Yeah, that's correct. So, even though we have this particular number over here, which is 8 million, right? We don't know what exactly this number over here is. So what can we do is we can add that particular number manually by going through each one of them and explicitly mentioning over here. Okay, so that makes it a much more comprehensible thing. Okay, before coming to that, let me just show you why we are changing here. So as you can see, we have these plots in this manner, right? But it is little bit more like interpretable when it comes to a horizontal plot. This is a vertical plot. So we're just going to flip the axis, okay? And for doing that, we just need to change .bar to barh. Everything else remains the same. Now we have a variation over here. Before we put the exact data regarding each of these confirmed counts, we can sort this in order to understand how the changes are. So we can just sort that in descending or ascending order. In this particular case, it's a high to low. Okay, so we're sorting the values and we're putting by in the case of confirm because we are doing for confirmed, right? And we're keeping in place equals to so that it happens in the same particular plot and everything else remains the same. And then we're just resizing. So as I just told you, right, some time back we had that size width and the height. Now we are using that same thing, RC params of figure size. We're giving 14 for the x-axis size and the 8 for the y-axis size, like the vertical and the horizontal size. Now we have the same plot, but it's scaled out a bit. Now what are we doing is we are adding some labels on the top and the side. So that is done using x label. Okay, we have x label, and now another thing that we did is we have also scaled it out here. Now what are we doing? Here in this case, we have a confirmed legend, but however, we have only confirmed over here. Is there anything else? No. So we need to remove that, right? So in that case, we just remove this legend by using the legend.remove. Okay. Because initially we used to initialize the legend separately, but however here in barhead, since we are giving x and y already, it's going to give a legend by default. We are removing that legend and making it more simple. Then we have the same super title and title to give, which will be giving ahead using, I think this is something we should have understood by now from yesterday's to today's course. So title is added. Then we have some styling. So we use ggplot even in line plot. The same ggplot is going to be given. So we have this contrasting set of colors. Okay. We have the legend font size, the label size, and the DPI. These are the same things that we saw even for the line plot. Then we have the scaling. We have the XY. We're setting the color explicitly to salmon so that it looks contrasting along the background, and a transparency. And everything else remains the same, the X-tick labels and the X label, legend remove, title, and title tag, so that it's more like compact. Now, as we discussed just now, we need to add these numbers, right? So that it's much more understandable about the exact number. The scale is not that clear. So how do we do that? So it's quite the code, right? That's the reason why Matplotlib is a little difficult to like for the beginners, especially. But once you understand, you have a lot of flexibility in terms of what you can do with a particular graph. So we are importing Matplotlib. We are from there, we are using RC, so we can set the font size and the font as well. Then we are using text if you want, or if you install it will work. It has been set to false by default. Then we use the ggplot for a background. Then we set the font size, axis, label size, the DPI. All we are setting it directly on the params. Or initially, like how we did, we used a dictionary. We can use all that. Like in the case of Matplotlib for line plot, we had made a single dictionary for all of these parameters, and we just passed it through the RC params towards the end. That can also be done, okay? So then now we have the same parameters for the plot.barh, where next we have the region, y is confirmed, color is salmon, and transparency is 0.8. Now we have a limit from 0 to 1.1 into max. So this is the confirmed limit. So it starts here from 0, okay? And it goes up to the maximum, but it gives a little bit more margin where it ends. So 8 million in the sense, it gives an additional of 10%. So around 5 lakh more towards the right, 8 lakh more to the right. So that now we have a much more like much better control on how exactly this plot has to be made. Till now we let it to the automatic decoder to interpret and plot it however it likes. Now once that is done, we have the y-ticks, the x-ticks, where we set the font size, tick label format, we set it plain so that it gives the entire number over here. Okay. And then we have the X label, the Y label, legend remove, and title. So basically it's the same thing that we did till here on the above chart. So you might as well keep it as this itself. That's not gonna be much difference. But in order to make this particular change, we have a for loop where we enumerate through each of the confirmed data. So when we enumerate, we're going to get an index. So using this index, we can plot for each one of these places. So index would be something like for 0, that or for America, is going to be this particular number in enumerate. So when we use data or confirm directly, it's just going to give us this. So we use enumerate, okay? And we are adding the plt.text with value plus a million, okay, a lakh. So what is this lakh? Is just we are moving that much distance towards the right. It's just a little bit padding here. That's the value for that. And once that is done, we have the index and the value that we are passing to that with the color of maroon and VA equals center. So that it's centered here. You can see that that's equal distance towards the left and towards the right with the size of it. So this is the main part that you need to remember. You can forget all this and you can just go back to this and put this amount of code in that and you'll have the same data over there as well. Probably you'll have to change the font size and the padding, but that's more than enough for you to do that. Now, don't you think that there are a lot more graphs that we can stack upon the same thing, right? So we use that. We call that as multibars. Okay. So for multibars, let me first show you how it looks. We have what it is like. Here we are plotting only confirmed cases until now. But in blue, we also have the deaths. As we saw in the data set, we have a lot more categories. In fact, we have confirmed, we have deaths, we have recovered, we can have active. We can plot all of them if we want to. But in this particular case, we are plotting only the deaths and the confirmed. So this is also simple, okay? All we need to do is when we have our data.plot_parh, we're just going to provide y equals to confirmed and deaths, okay? Everything remains the same until we have to provide the number for another for loop, and we have to display the number even for the deaths, okay? So we have an additional for loop here, and we have an additional parameter in the data dot plot dot parh, and everything else is sorted on its own. So by just adding a couple more lines, we are having a much more better understanding of the same data, and we are able to see a comparison between the categories, right? So what did we explain about bar plot? I said that it is used to see the distinct changes in the distinct categories, right? How do we compare the values between distinct categories? That's the main motive behind bar plots. So that's what we're trying to achieve over here. We can see the difference between a confirmed case and the deaths that has taken place in each one of these areas and how it compares to each other. Now, what is a stacked bar? So till now, what bar is this? It is a multi-bar, which means we are going to keep them side by side. But when stacked, I think the name is self-explanatory. It's going to stack the same thing over here to the right. Okay. So it's going to look something like this. And we're going to give a cumulative count. And the other count is going to be given over here. So when we do that, okay, that's a little bit discrepancy in the way it's supposed to display the numbers. Maybe we can fix that later. But overall, the change in our code. So first, to start with, we have BARH and we are giving y equals to confirmed and death, which is the same as before. All we need to do is change the stack from false equals to. This is the only change that's happening from this particular code, okay? Here, we do not have anything called stacked. When we enable it as true, we are going to change that code into displaying something which is stacked like this, okay? It's as simple as that. We can give in more variables also if we want to. Now, coming ahead to the proportional bar. So when we have a proportional bar, it's going to scale them to the maximum, okay? So the 100% would be a cumulative of each one of them. But you can see a proportion. So here the intent of this graph is not to see the exact count, like exact total, but to see the relativeness, the relative correlation between death, active, and recovered. Like death is the least. Active, it's almost as much as recovered, right? And in Europe, we see a higher amount of death and higher amount of recovered. And active is slightly smaller in comparison with Americas. So we are able to make a lot of categorical comparison within categories and across categories, right? Now, polar chart is something I would like to give you as a homework. Okay, so this is something you can take it up today and we can discuss it in tomorrow's class if you have any doubts. Okay, so polar chart is going to represent this same data in a much more interesting way. Look at this. Doesn't this look like really appealing? We can get even the magnitude, and at the same time we're seeing how many we're seeing the differentiation between these different places. Like for example, for the Western Pacific, it has the least amount of data, the least amount of just a second, of confirmed values. Yeah, so these are the number of confirmed cases. We have the least number of data, least number of confirmed cases at Western Pacific, and then it's slightly increasing towards the Americas. Okay, so just go through the code. And if you have any doubts, we can discuss it tomorrow. Okay. And let's move ahead to doing the same thing with Seaborn. Just like how I explained for Matplotlib, I'll show you the comparative differences from both Matplotlib to Seaborn. Okay. So here we have data.plot.bar and we are giving in the x and the y. Here we just have SNS. SNS stands is what we set the import of Seaborn as. So Seaborn.bar plot with xy, and we're setting the data. And we already have a much better data as we see that it's stacked over here as a vertical way, and here it's horizontal. It's much more interpretable already. So you see a better, and also the legend is not coming there by default because it's able to understand that it's just a single category that they are displaying. So you can see the difference from Seaborn to Matplotlib already. Now we just do a tight layout to make it a little bit smaller. Okay, so it's the same thing. Now we rotate the same thing if required. This is just to show you a comparison of how the code is running across the two. Is the same thing. X takes rotation of 30. So you'll think, why is there a combination of SNS and PLT? It's the same as in the line plot. PLT, since SNS is working on top of Matplotlib, it's going to be having some common syntaxes which will work across. Okay, so that's the reason. Now, moving ahead, as you can see, there was one issue in uh, Matplotlib which was giving 8, and the same issue is there even in the Seaborn output. So we just need to do axis equals to y and style equals plain using the tick table format. That's going to give the same answer as that. Okay. Now we're going to just flip the axis by using a bar plot where we give y as region and x as confirmed. Here, what we did in this case, we have done bar h. But however, here we're just changing the way in which we are giving the variables. So y will get region and x is going to get the confirmed cases. That's the change. Then we are sorting it. So for sorting, we have a data.sort. So instead of sorting through this, we're just sorting like the previous data frame itself, and we're keeping it in place so that it changes the entire data, and we have an ascending equals false. So we have a descending order that's happening here. Okay. So moving ahead, we are just resizing it using 14, 8. Then we're adding X label access. So confirm COVID levels using X label. That's as straightforward as possible. Setting the title. Now we are adding much more. We are using the ggplot, the font size, label size, DPI. So we're setting the figure size. Then we're sorting the data. I think let me just split it out. Then sns.barplot, and we have the labels for the same, and then we are doing that, right? So it's the same data, and we're just adding some styling to the same thing, which is what we are doing over here. So you can see that we're getting a very identical plot for both of them. Okay. So moving ahead, we are adding the bar to add the values for these explicitly is the same for loop as before, since as I told, Seaborn has an underlying Matplotlib engine, like it's based on Matplotlib. So the syntax is going to remain the same. Then moving ahead for multi-bars, we are going to have sns.bar plot where we have y equals region, and okay, let me open this as well. Yeah, for the multiple plot, we have a bar plot where we have y equals region, x equals to value, we have u equals to variable, and data equals So what's happening here is that we're plotting the deaths, right? When you the deaths along with the uh, confirmed dates, confirmed cases, right? So we're doing that over here, and this is all the same data, same code as what we were explaining before. So that is all with regarding to the multiple plots. Then the stacked bar. Uh, so as we go ahead, we would see that there's a lot of commonalities between uh, this Matplotlib and Seaborn. There's very minimal changes because now we both have almost a huge amount of code for both of them, right? I think like we are saving a couple of lines or at max when we come to Seaborn, but it makes the syntax a little bit more easy. Okay, so we can take that as a positive aspect at this point for the case of Seaborn, as we can see that we have region here at y-axis and x as total, and we're changing the color, and we have the data. So that's the same syntax as before. And since we are plotting the same thing along the same y-axis and the same x-axis, it's going to be stacked. In the previous case, when we were stacking, we were setting that particular variable stacked equals 2, right? Here we are adding another line where we are plotting along the same axis. And since we have the same y, it's going to be overlapping the same. Okay, so omega is going to be the same. So it's going to stack over here on top of that. And then moving to proportional parts is going to look like this in comparison. And in order to do that, we have three different plots like how we did previously. And we have the x equals region, so it's common, which is why it's going to stack. Then we have x max and then up till active and then the depth proportions. Okay, so then we change the colors and then we give it a label as depth, then the data, and then transparency. Then the rest of the code remains the same. We're just adding the legend, enabling it, setting the axis, and setting this to plain so that it enters the entire number. And yeah, so that is more than it. Now, there's an issue with the polar chart. Here, though we can plot it for Matplotlib, there's no inbuilt way to do it with SNS, that is Seaborn. So we have to stick with Matplotlib for that. And do you have any doubts before I go to Plotly? So when we come to Plotly, loading is the same. Now we load the Plotly using px.bar for bar graph. And when we have data, we set the x region and y as confirmed. Now going ahead, we just change the colors by setting the color as confirmed. Okay, the Plotly is going to on its own do a lot of changes so that it's much more interpretable and much more interactive. That was a key highlighting feature I told, right, about Plotly. So you can see that it has much more interface. Like you can also see that my cursor is going to a contrasting color to what I'm selecting. Here is going to green when the background is dark, and here is going to blue, which is again contrasting to its background. We also have a color legend here, which shows what's the case. So we have a much more analysis. Also, you can see here, it shows 8M. Here is just 8, right? So it's much better for us to understand that, okay, 8 million. Oh, wait, how is this moving, right? So it's, as I told, interactive in the sense it's interactive in all ways. We can zoom through each one of these places. Okay, we can auto scale it, zoom out. See, it's extremely interactive. This is what I was saying that I'll come to later on. So we can also save this as a whatever we needed to save as, and then zoom, and we can do that box select, and yeah, lasso select. Doesn't this look like Paint 3D? It's doing all of that in just a normal representation, right? Okay, so coming to this, next we're going to rotate this x-axis manually using tick angle equals -3, which is, so we are setting this entire thing to a variable and we are updating a parameter in that, okay, using this tick angle of -30. Then to make it horizontal, we just need to add a parameter orientation equals h. Then when we have to sort it, we're going to sort the original data as we did before. So that's the easiest way instead of relying on any sorting to be done by the libraries that we're using. We're going to sort the actual data and keep it in place so it's applied for all the data in the future. Now we're going to resize the graph using width and height, as straightforward as it gets. Add a title using the title parameter. So I think you would have noticed that until now we're using a single line of plot and a single sort. All that's required to reach what we have reached here after so many more lines, right? We have reached this exact position. Okay. Um, yeah, this exact position with just one or two lines of code. This is how we see that Plotly is much more concise and at the same time interactive for our usage. So this is why I told in the beginning that Plotly is the favorite one for me. It's easier for me to explain it to you guys, right? So when we go ahead, we can play around and we can change the position of this, right? So it was towards the top. We are going to place it in different locations by just using X anchor, Y anchor, center to the bottom. You can see it's center to the bottom and with some of the padding which is required. And then we're going to add up the values to the bar explicitly. So how do we do that? You remember that this was the code that we used with one huge for loop to add the code over here, to add the numbers, right? So what we do here is once we have sorted the values, we have the same title towards the bottom. You can ignore all this. We can directly go to this update layout. Sorry. Okay, let me go step by step. This is the entire thing that we have done so far, right? Once we do that, we update the traces where the text position is outside so that it reaches over here, this part. And um, once that is done, we are updating the layout. We have a title equals title. And what we're going to display over here is going to have a range from 0 to 1.1 times the max. Okay. Now, once just by adding this one text position at outside, we are going to have that entire count that is going to be displayed over there. Okay. So that is the advantage of using Plotly. And when we have to go to multi-bars, it's even more simple since we just need to change this one thing where we have x equals to confirmed and that's in a list format. Okay, so it's going to take it automatically in just one line. We are achieving what it took with these many lines towards the left. It's just so much. That's one dictionary and couple lines to plot them and one sorting. This is a huge for two huge for loops. All these plotting, all these labels, all these parameters, and all these styling, right? So do you see that it's much more simple already? Now going to the stacked bar, we are going to have the bar mode h equals stack, and that's all that's required to make it even in stack mode. In comparison with this, right? And when we hover over it, we can see the value also. So that's also again useful for us. And finally, moving to our proportional bar, we have this proportional bar where we set our width as a confirmed one as 1000, so it all reaches to this particular location. We have the same region. We have x equals to equal to the three categories that we're displaying that's displayed over here, and then we have our orientation equals horizontal, bar mode stack, and opacity width. So once we do this, right, it's just extremely simple to achieve what's done by Matplotlib with a lot to get the same thing. And coming to polar chart, let's discuss that tomorrow. It's simple, not exactly simple, but it's something that you can explore and understand. It's going to represent the relative sizes, what a bar plot does, but in a more stylish manner. Okay, so you can see towards the left we have the Matplotlib, and here you can see that there's a lot. That's some kind of explanation here in terms of you have more interactiveness in the same data here, right? Mm, I'm really not sure how to undo what I just did. Okay, let me just run the codes again. Okay, yeah. So yeah, basically this is all about bar plot using Plotly, Matplotlib, and Seaborn. Do you guys have any doubts? We have come to an end in terms of the explanation.
One of my questions, you probably mentioned this, is are these like Matplotlib and Plotly and Seaborn, are they used mainly for bar graphs or are they also used for line graphs to improve like the visualization of it?
No, all of these have support to multiple graphs. The Matplotlib has support to most of the graphs, okay? Like for example, area graph was not present um, in Seaborn, but it was present in Matplotlib, right? So when you come here, this area plot was inbuilt for Matplotlib. However, it was not inbuilt for Seaborn. So there are some trade-offs here and there. Seaborn is trying to make it simpler, and Matplotlib is complicated, but it has more access to different kinds of plots. And of all of them, the highlight about Plotly, right? It's about the web interactiveness. So we can directly embed them into a website, and it has an interactive interface, right? So that's the advantage of using Plotly. So it also has a access to a lot of plots, but maybe it's little lesser and less customizable comparing the Matplotlib. That's the thing. Does that answer your question?
Yep, that does.
Yeah, this is the thing. So Matplotlib for highly customizable plots, Seaborn for automated plots, which is also based on Matplotlib, and Plotly for interactive plots. So that's where you select what to use.
So we can't import Seaborn without also importing Matplotlib.
No, when you import Seaborn, it's more than enough. You can just import Seaborn as SNS, and the thing is, a lot of functions in Seaborn requires Matplotlib, so it's better you do both because we use PLT in combination with SNS, right? Yeah, you'd have seen that. So mostly, yeah, that's it's not a necessity, but it's a recommended thing to do.
Okay, got it.
Not because SNS is dependent upon that, but because we need it to do some functions. Then any other questions? Okay, I think you guys have understood everything. So